Today's presentation is titled Radiology as a Service and will be presented by Dr. Murray Reicher. Dr. Reicher is the founder and chairman of former PACS company DR Systems and is currently CEO of Synthesis Health. I'm going to turn it over to Dr. Reicher now.
Hi, welcome everybody. Thank you for attending the meeting today. I'm going to recognize that we have a fairly small audience, so please, if you have any questions, enter them into the chat. I think our webmaster can open this up to a conversation at some point here soon as well, but please make it as interactive as you'd like. So today I'm going to be looking at this new business that has emerged really since COVID that I will call Radiology as a Service, and I think other people are using that acronym as well, or that moniker as well. Let me give you an outline. In the next 30 minutes or so, I'll be discussing the radiology shortage and the new job mobile radiologist. Take a look at who's buying technology today in the radiology reading marketplace. There's really been a seismic shift in the market as to who the buyer is. And we'll also take a look at the technology requirements for this new industry and give you a preview of some technology that's in the market today. I'm going to try to keep this discussion as vendor neutral as possible. So first, the radiology shortage. Anybody who is a clinical radiologist today knows that there's a shortage of physicians in general and radiologists in specific. It's not a problem that we're going to solve through training alone. So we do need technology to expand the capability of the radiology workforce. It doesn't just affect radiologists. It's a problem that we also have with technologists and other radiology support personnel. The global market for radiology has been growing steadily for decades. Probably averaged 6 to 8% CAGRs since the late 1970s. And the reason for this is simple. Medical imaging just keeps becoming more and more capable of non-invasive diagnosis and minimally invasive therapy. If you think about it, when a patient goes to see their internist or other primary care physician, most other physicians, the value proposition for the patient is the time spent with the doctor. And that's important. I like to spend time with my doctor too. But from a business viewpoint, it creates a real business model problem for medicine in general, because for doctors to get more efficient, they've got to reduce the amount of time that they spend with patients, and the reduction of that time inherently destroys the value proposition. The patient's there to spend time with you as a doctor. But when a patient goes to see a radiologist, it's actually quite different, right? Because the ideal episode for an MRI or a CT from the patient's viewpoint is the exam was painless, it took a minute, and the report was available a second later. They don't care whether they've met the radiologist or not if the radiologist is not doing an interventional procedure. There may be some exceptions to that. Mammography, for example, I think patients do value getting an immediate result and an explanation from the physician. And perhaps they would for other medical imaging procedures as well. But the bottom line is most radiologists, despite all the articles written about how radiologists should become more clinically involved in care, the trend in radiology is actually the opposite. The number of exams is increasing. The number of images per exam is increasing. The training is relatively flat, and the shortages just keep growing. So currently, I think there's something like 1,400 job postings at the FACR website for radiologists. Techs are in high demand. Hospitals are beginning to have to curtail services in their emergency rooms and other aspects, and even we have hospitals with threat of not being able to keep their doors open simply because they have insufficient staffing. So what we're seeing is more and more radiologists are forming into larger groups, and even sometimes the groups don't have to be that large to offer a remote reading service. Whereas 5 years ago, I would say most radiologists still would not have described themselves as teleradiologists. Today, virtually every radiologist is a teleradiologist in the sense that we all read exams remotely. Even if you're parked in a hospital, you're probably reading exams that were done outside of that hospital during your day's work. So if you're providing services to a hospital or a medical imaging center or group, medical imaging center group, what are the criteria that make you competitive? Turnaround time, and to provide a great turnaround time, you have to have an expandable workforce that expands as needed. You have to have your hand on the pulse of what's going on within your organization, so that if you're behind in critical results, you can bring people in who can help you with that. You have to have a clear, trackable prioritization of your work and adherence to the contract commitments that you've made. People actually care about accuracy as well. That means subspecialty readers. It means industrial measures of quality, statistical peer review data, not just, well, we're all board certified radiologists that are former chief residents from major universities, but we peer review 40% of the exams that are read, and our agreement rate is 97 or 98%. You need reports that go through rigorous evaluation, whether that's using AI, other means, in order to document that your reports are consistent and high quality, that the quality is improving over time, and that the recommendations made in reports are not simply recommendations to medically legally protect the radiologist by recommending additional studies that may not be necessary, but they're recommendations that are credentialed recommendations based on guidelines that are referenced. And then finally, security is an important consideration. So as a teleradiologist selling my services or my group services to a hospital, I want to be able to say, as I recap, that my services are prompt and expandable, that my accuracy is high, and that I don't put PHI at risk because I'm reading remotely. I want to be able to say to the facility, if you hire me, you're not going to have unencrypted patient data at rest in a remote location where a lost laptop or a burglary in a home puts the entire organization at risk. Let's talk a little bit more about the radiology shortage, where we were until now and recently, and in the more distant past, and where we're going into the future. So, as I've mentioned, in the past, radiologists mostly worked locally. Most were generalists. Many crossed between interventional radiology and diagnostic radiology. In my career, changing my job meant selling my house and pulling my kids out of school. It was a big deal. Generally, radiologists were in groups where radiologists shared income and split costs, and they typically billed, at least in the private practice of radiology, billed separately. The patient could expect to get an independent bill from the radiologist that read the exam, even if that exam was done in a hospital or in an imaging center where the technical component was owned by somebody else. But that's all changing now. So today, almost all radiologists read remotely. And as I said, even if you find yourself parked in a hospital working today, some of the exams that you're reading probably were obtained off-site. Most radiologists describe themselves as specialists, not general radiologists anymore, and they've recognized that reading within their subspecialty not only improves quality, but it improves efficiency. And efficiency is key for radiologists because we're piece workers. We make more when we read more. So specialization improves the quality of the work we do, but it also improves the compensation for the work we do. Interventional and diagnostic radiology are becoming more and more divergent. It's less and less common to find a diagnostic and an interventional radiologist that it's less common to find a radiologist that has both skill sets. Interventional radiology, interventionalists are becoming hospitalists, basically. I mean, there is IR in the ambulatory arena, but if you measure it by dollar, it's mostly in the hospital arena, or more than mostly. The vast majority of the dollars are in the hospital arena. And so interventional radiologists are more like hospitalists, and diagnostic radiologists are more like, remote diagnostic pathologists. Changing jobs today can happen as quickly as changing a bookmark in Chrome. So the job mobility is unbelievable. Many radiologists have 2 or 3 jobs. Teleradiologists often have multiple jobs, and they switch their time into whatever job offers them the greatest economic opportunity, as determined by the most efficient technology. Doctors no longer want to pool income. They want to earn their living based on the work that they do individually. And we're also beginning to see a move away from separate billing, even in the private world, into global billing. Teleradiology companies typically will bill a hospital or a radiology group, if they're subcontractors, a fee per work RVU, and the patient doesn't get a separate bill from the teleradiologist. In addition to that, more and more we're seeing the teleradiology group providing the reading technology and even charging for that technology. So we're seeing a future model where hospitals and imaging centers own the archive and the enterprise viewer, the viewer that patients and referring doctors use, but the PAC system is being purchased and managed by the teleradiology group. That began actually over 30 years ago. Hospitals would go through arduous selection processes, and IDNs would go through arduous processes in order to build consensus to determine what PAC system they would put in during the day. And then at 10 o'clock at night or at midnight, the teleradiology group would come in and use whatever system they wanted to use to do the reading. The only major shift that's happening right now is that sort of mentality has moved to 7 by 24 by 365 instead of just weekends and nights. Let's also look at, therefore, who's buying today. So in the past, as I said, the hospitals owned the PACS, the VNA, and the enterprise viewer. There were often long, arduous RFP processes with multiple trips to the RSNA and other meetings. There was a typically long implementation process. Trainers came on site because the doctors and the techs were on site to receive the training. Often there was what I call the Frankenstack, lots of vendors for information technology and radiology all interfaced together in order to formulate a global working system. The radiologists built separately, as I mentioned. Exams were mostly read on site, and without subspecialty reading, there was pretty much an open work list. You read the cases as you picked them off of a work list to read. And then after 10 p.m., teleradiology took over, beginning in the late 1980s. But today, and more moving into the future, the model is really different. The hospitals are today own the archive, and I believe the hospitals will own the archive and the enterprise viewer moving forward, and not just hospitals, but organizations that own multiple imaging center groups. The long RFP process is giving way to more of a try and buy mentality. Cloud-based, comprehensive medical image management and reading systems are making it possible for people to have a reading overlay to their existing PACS system so that they can try reading on a different system, and if they like it, turn their PACS off later. That's a very different model. And so I would say, rest in peace, RFP. It was a political process that was probably not ever scientifically validated. I think having expertise and consultative expertise when you're buying is still highly valuable. But I think the 600-page RFP and the highly political 2-year selection process is giving way to the try and buy mentality. All radiologists and teleradiologists are beginning to provide clinical workflow technology. So it's not just the telerad group that says I'm reading on what I read off of from midnight to 6 a.m., but it's happening 24 hours a day, where the rad group is saying we're going to have our own PACS system. We cover 5 hospitals. They have different owners, yet we need one system to read off of. Global billing is becoming more common, still not the rule, but we're seeing it grow, where the hospital is paying the radiology group a fee per RVU and global billing the patient. Built-in training and webinars have increasingly replaced on-site training. What does on-site training even mean when a radiologist is reading from home? Are trainers going to go to the radiologist's office or den or bedroom in order to train them? Not going to happen. So, and flying people around the country to try to catch, people one at a time in a 30-person group when 4 of them are on vacation this week, it never worked well, and it's going by the wayside. In addition to that, we're seeing greater and greater subspecialization, and that demands automatic exam assignment. More and more radiology groups are no longer reading off of an open work list, but in fact, radiologists are reading the exams that they've been assigned. So all of this results in a set of technology requirements. And I want to just summarize for you, if you're in the technology marketplace, what those requirements might be. Or are. So the first thing I would say is, beginning in around 2008 to 2010, we saw the beginning of pure cloud-based viewers, where the diagnostic viewing software was no longer a program that was installed on your computer, but something available on the cloud that could offer the advantages of, much faster upgrades, much less requirement for IT support. But the problem with these zero footprint viewers for production radiologists is that they're slow. When a radiologist goes to read the next case in a list of exams, the expectation is that all of the images and for the current study and all of the images for the relevant comparison studies will be present nearly instantly, certainly within 3 to 5 seconds, along with all information necessary to generate the report. And that just doesn't happen with cloud-based viewers. Pure cloud viewers historically streamed information, and streaming it's great when you're watching a movie, because if the movie stream is 10 seconds ahead of where you're watching, as a user, you're perfectly happy. But a radiologist can look at an exam and decide in the first second, I'd like to do a 3D reformat of this entire exam, or window level all, or 3D targeting, see the cross-reference lines for all the images, match a particular series from the current exam to a particular series from the prior and the prior before that. And that just can't happen while you're waiting for images to stream. So what the industry, I think, has been waiting for is a zero footprint environment where you can have the benefit of pre-caching, where you have the benefit of the system knowing, just like it did with old fat client viewers, what case you were going to read next or this week, and having all of those cases available pre-cached to the local hard drive of your computer, where you could randomly access the entirety of an exam and the relevant comparisons. And that's a huge breakthrough in this space, that ability to have a zero footprint viewer that pre-caches. And the reason it's a breakthrough is because it's just so much faster when the radiologist is reading. The next thing is, cybersecurity has become a huge thing. So it's critically important that there be no protected health information present in remote locations that are vulnerable. And I think the days of the fat client viewer with a week or a month or a year's worth of images sitting in a radiologist's bedroom or in a laptop that you're carrying around, it's just too risky. And now that we have solutions that are better, and now that we have zero footprint viewers that can pre-cache, that don't require PHI in a remote location, I think anybody providing teleradiology services will be at a serious competitive advantage in contracting if they offer that type of technology. It just puts the hospital or the imaging center owner and ultimately the patient at much less risk. Automated exam assignment and dashboards associated with the status of exams, constant surveillance of turnaround times of critical results. Technology has to support that. Interoperability is key. You must have HL7 and DICOM connectivity to electronic medical records and vendor neutral or other forms of medical imaging archive. So that's a key point. Data normalization is often overlooked as a very critical requirement in this space. What do I mean by data normalization? Well, suppose I read for 5 hospitals, and hospital number 1 in their compendium, they have chest PA and lateral, and chest lateral decubitous, and chest AP and chest PA. And another hospital calls it chest 2 view, 1 view, 3 or more views. And another hospital has a completely different nomenclature for each of the exams. And in one of the hospitals, the body region that is in the DICOM header file from these CR or DR vendors is filled in one way, and in another hospital it's not filled in at all, and in another hospital half the equipment provides that information, the other half doesn't. And in one case the body region is called the chest, and another one it's called the thorax. Although radiology has been trying to develop standards for 40 to 50 years now, some of the standards are poorly enforced, particularly body region organization and exam descriptions. And so it's easy to get into a situation where, as a teleradiologist, you're reading for 5 sites, and there could be 15,000 different types of exams in your compendium. And every one of those exam types has to be linked to the other exam types in a sort of one-to-one matching system in order to have any hope of seeing the proper comparison study, the proper templates, the proper tech forms, the proper hanging protocols, are all dependent on the exam type table. With data normalization, the technology converts all of that information into a standardized compendium, standardized modalities, standardized body regions, standardized exam descriptions, standardized work RVUs, standardized report templates, standardized technology forms, or technologist forms. And that simplifies implementations by a factor of 10 to 100, and it also makes it much easier to maintain systems, and it makes those systems much more reliable in terms of the presentation of relevant prior exams, the consistent adherence to hanging protocols, and more. Another key requirement is systems today need to be comprehensive. At one time, it was okay to have 5 or 10 different information technology vendors strung together to keep your radiology department working. Today, it's just not affordable. It's not very functional either, and it results in a poor user experience. So, the analogy I use is, I've got a cell phone that it's not just a phone, right? It's a phone, it's a video camera, it's a regular camera, it's a slow motion camera, it's a browser, it's a note taker, it's a tape recorder, and many other things, okay? And I have it all in one place with one user interface that I can understand. And I think people are crying for that in radiology as well. The next requirement, I think, is a little more subtle. It's the idea that our technology needs to be informed by cognitive science. Most of the reading technology developed over the last 30 years was designed to mimic the experience that radiologists historically had while looking at film on a view box. There are better ways to do things today. We watch radiologists read, and even though we're more efficient than we've ever been in the past, we're still pretty inefficient. We spend our time dividing our attention between the report and the medical images, and that's the equivalent of texting while driving. The human brain is not very good at dividing attention between two tasks, even though we suffer from the delusion that we are good at it. So I think it's possible to develop workstation technology that is informed by what science knows about the way people actually perceive and diagnose pathology on medical images. Other technology requirements include the need for dashboards and management reports so that we can constantly be aware of our productivity and accuracy and improve it, built-in peer review, workflow for residents and other types of pre-readers, integration of artificial intelligence. Obviously, security is critical, and whatever system you have, it has to be dependable and fast. So with that, I want to just give you an idea of some of the technology that I've been involved with. This is an example of a reading system where everything is on one monitor, where there aren't a lot of head movements and eye movements, where every exam is standardized, where RVUs mean something because they're applied to a standardized compendium of exams, where it's possible to toggle, where it's possible to generate a report without taking your eyes off the images, and it's possible to go from looking at images to other forms of documentation, including the current exam, prior exams, prior documents, prior reports, all on one screen. When I mention reading informed by cognitive science, I want to show you some examples. So here we have two images that are displayed side by side. This is a setup that is way more ideal than the typical radiologist ever encounters, because these images are scaled to the same size, they have the same grayscale, and there's only two of them, whereas a radiologist trying to compare a new CT to an old CT might have hundreds or even thousands of images to compare. And yet, it's a tough task, right? I mean, I think in 15 or 20 years, we're going to look back at this era and find it almost unbelievable that radiologists spent their day first eyeballing images to look for the anomalies and changes. That's going to be done by a machine. After all these years of training, the typical radiologist, I think, should spend their time analyzing not whether there's a finding, but the significance of the finding and what it means with regard to the patient's diagnosis and recommendations for therapy. But at any rate, while I've been talking, you've had an opportunity to look at these two images and hopefully see some of the differences. And the question I have for you is, when are you done? Have you seen all the differences between these two images? Or is there a cancer here that appeared on the new exam that wasn't there previously on the old exam? And when are you done? When do you say, I'm finished? I'm satisfied that my search is complete? Is it after you've made the first finding, or the second, or the eighth, or the ninth? So let's look at these images in a completely different way. And instead of looking at them side by side and comparing them, let's flicker between them. So this method has been studied. It's not used very broadly in radiology, although it's used very broadly in other fields like astronomy. And you can see that when I flicker between these two images, the differences become much more notable. And this doesn't depend on perfect registration. Unlike subtraction, the human brain accounts for movement between the two images. The reason that you're a better detector of pathology when you flicker between images is because you're detecting motion. And anytime you can turn a radiologist or any human being into a motion detector, we're just inherently better at it. We can detect motion without the fovea of our retina. The side-by-side method requires a different part of our brain that has only recently evolved. Same thing here. I'm looking at two CT images side by side, and you may focus on a nodule here perhaps and say, is this patient better or worse? Well, is the nodule bigger or smaller? Has it changed in density? Has it moved in position? Is it becoming cystic? Those types of decisions require radiologists to start making measurements. And yet, if you flicker between those two images, not only can you say with a high degree of confidence that that nodule has not changed at all, but you may see other findings that become a little more evident to you, like the gorilla in the lingula, or the 1-pixel nodule in the right middle lobe. So flickering is an example of how we can make medical imaging better. Next, this is an example of a screenshot that just shows automated exam assignment and a dashboard that provides you visibility into how your practice is working, which radiologists are available, who's not available that could be called on at any point in time. Simplified work list with a standardized compendium of radiology exams so that a radiologist reading for 1, 2, 50, or 500 hospitals feels like they're reading for one location. Here's an example of a technology called speech organization, where instead of having to take attention away from images onto reports and step through a report in order to read a case, instead of that, the radiologist can launch a dialog box and dictate information in any order that is then turned into text, parsed, and inserted into the proper location of the report based on natural language processing. Here you see an example of a conclusion being automatically generated as a result of the dictation of the body of the report and other information about the patient's history. Here's an example of a chest x-ray on the left and a chest x-ray on the right, where a system has selected the prior exam, scaled it, presented my individual report template on a screen, marked the areas of the chest where pathology was detected by an AI algorithm, and even extracted information from the previous report dictated by another physician and embedded it in the report template so that chronic findings don't have to be redictated. So here's another example of modern technology improving the efficiency of radiologists. Here, AI has looked at an exam of MRI exam of a patient's hip, presented the series of images that are associated with the current exam on the top row, prior exam on the next row, next older prior exam on the next row, and finally the oldest relevant prior exam on the next row, and auto-matched the image series so that the best matching comparison image series are aligned side by side, saving the radiologist the need to rearrange these images. This is another example of technology for mammography. Traditionally, when radiologists read a mammogram today, they use CAD. Here, CAD, the blue triangle, identifies an area of suspicious calcifications, but there's also a reporting tool. The reporting tool allows the radiologist to accept this CAD mark, and have the location of the lesion automatically reported without having to dictate it. So it takes a radiologist literally 1 to 2 seconds to see the CAD mark or the lesion. It takes 12 to 15 seconds to say left breast, upper outer quadrant, 2 o'clock position, mid breast depth, 7 centimeters from the nipple seen on the CC and MLO view. There's no reason why a doctor should have to say that text 150 or 200 times a day. Have the possibility of saying left when you mean right, 2 o'clock when you mean 10 o'clock. The stress associated with having to think that through for every exam. Physician should be able to click, and have the location of the lesion described. And so on and so forth. This is an example of technology where the spine levels are auto-labeled, and instead of a radiologist having to dictate the abnormality at every disc level, based on the auto-labeling technology, the doctor can click some buttons and generate the text that describes various disc, vertebral body, spinal canal, facet, foraminal, or neural abnormalities. So there's a lot we can do with technology to support this new radiology as a service industry. If you're a radiologist or a radiology administrator, the one constant that I can say I've observed over my last 40 years in the field is that things are always changing. And we continue to see change, I think change for the positive in terms of the efficiency and quality of the work that we do, and the ability to benefit patients and the referring doctors that refer those patients to us. Thank you for your attention. I'll pause now and address any questions.
Great. Thank you, Dr. Reicher. It was an excellent presentation. You've given us a lot of things to consider, especially the technological requirements. I know personally I've seen RFP changes in the past 5 years that are significant, and noticing that same trend that you brought to the to our attention about the radiologist wanting to purchase their own packs, and then just having the VNA and the enterprise viewer be the decision being made by the facilities. So I appreciate the time that everyone has given us on today's call. This presentation, as well as the first one, will be available streamed. It'll be available on RadHQ's site, as well as Dr. Reicher's company site, synthesis.health. So with that, we'll go ahead and call it call it a day. And we look forward to meeting with all of you probably in another 6 weeks or so, as we have the third presentation in the RAD HQ webinar series. Thank you very much. Have a great day.